Okay, so in our last concept for this unit, we're going to analyze and graph these complex rational functions. All right, so remember, a rational function is basically a polynomial over a polynomial. What we're gonna do is get the right thing. We're gonna find x and y intercepts. We're gonna find vertical asymptotes, horizontal asymptotes, and graph. All right, so here's domain and range. So here's the thing, okay, what you're going to be expected to do. And so for me personally, I have like the little notes that I've taken from the unit, okay, just written down, because some of them are, I mean, they're brand new concepts and they're super easy to forget. And so if I'm looking, that's what I'm looking at. And so what I'm going to do is I'm going to write the things I need to find. Okay. So this is our function. All right, and so this, what I do is I try to factor if I can. So sorry. I try to factor anything I can. So that bottom guy right there, I can factor. So this function I can rewrite 3x squared over x plus 2x minus 2. Right? And so then we need to find these things. So I'm going to go on the next slide, and I'm going to find some of the stuff, and I'm going to come pop it into our graph organizer. All right, so this guy, we rewrote it as 3x squared over. Okay, now we need to find the x and y intercepts, vertical asymptote, horizontal asymptote, domain and range. Okay, and sometimes it will be more useful to use this one, and sometimes it will be more useful to use the one that's already factored. All right, so I'm going to go back and forth. All right, so for y-intercept, that's when x equals 0. So everywhere there's an x, I'm going to plug in 0, substitute 0. So I get 0 over -4, which is just 0. So my y-intercept is 0, 0. I'm going to go write that down. Okay, now I need to find my x-intercept. Oh, I must have gone 2 slides on x. Right, my x-intercept is when y is 0. And so basically, what you're going to do is you're going to set the numerator equal to 0 and solve. Okay, and the reason is because we're going to really set this guy equal to 0 and solve, and so we multiply the bottom by 0, we get 0, so we still get 0 equals the numerator. So 3x squared equals 0. I'm going to divide by 3 on both sides, and so I get x squared equals 0. When I take the square root of 0, I get 0. So my x-intercept is also 0, 0. All right, vertical asymptote was you solve the denominator. Okay, vertical asymptote. Okay, remember this is the same. Okay, the vertical asymptote, you solve the denominator. And so we can either solve, like, set x plus 2, x minus 2 equal to 0 and solve. And so we set each of those. Or we could say x squared minus 4 equals 0. Add 4 to both sides. Then we take the square root. And so the square root of 4 is 2, and you write plus minus. And so the vertical asymptote is x equals minus 2. Horizontal asymptote is you compare the degrees. And so here, the numerator degree is 2, the denominator degree is 2. And so 2 and 2 and they're equal. And so when they're equal, you look at the coefficients. So you put the numerator over the denominator, and so we get 3. So that's our horizontal asymptote, is y equals 3. Right? And alrighty then. All right, and then we look at our domain. So basically, our domain is vertical, horizontal is range. And so our domain is all real numbers except x equals plus or minus 2. And our range is all real numbers except y equals 3. Okay, so now we're going to put it together. So right here we have a intercept. Then we have vertical asymptotes at 2 and negative 2 and 1 at y equals 3. Right? Then I feel like my calculator is going to die any minute. All right, I typed it on my calculator. And so that's the graph. Okay, and sure, you could type it in the calculator from the beginning, and you can just draw these guys. But then you wouldn't know your analysis, and you wouldn't get points for all that, and you wouldn't know what any of this means. Let's do another one. Right here. So we have x plus 10 over x squared minus 2x minus 3. All right, let's do the y-intercept. And so the y-intercept is when x is 0. So I'm going to do 0 plus 10 over 0 squared minus 2 times 0 minus 3. And so I get 10 over 0 minus 0 minus 3 for negative 3. So I get negative 10 thirds. So I'm going to write that down. Negative 10 thirds. 0, negative 10, 0. X-intercept. X-intercept, you set the top equal to 0 and solve. So we get x equals negative 10. So we get negative 10, 0. Intercepts are always ordered pairs. Vertical asymptote is when you set the bottom equal to 0 and solve. So we're going to figure out what multiplies to give us negative 3 and to give us negative 2, 3, and 1. Negative. So we get x minus 3. X plus 1. So we will get x minus 3 equals 0. We'll get x equals 3. X plus 1 equals 0. So we'll get x equals negative 1. 3, negative 1. And then horizontal asymptote, we're going to look at the degree. So the numerator is 1, the denominator is 2, and it's less than. So when the numerator is less than the denominator, it's y equals 0. And then you write the domain and range. So you could say all real numbers except x cannot equal 3 or -1. So that's another way to write it. Or you could say all real numbers except y cannot equal 0. Right, -10/3, -3 and something. So somewhere right there. 10, -1, and 3. Just pretend that's a 3. And then 0. Right, and then we x plus 10 divided by, make sure all of the numerator is in parentheses and all of the denominator is in parentheses. Okay, and then graph it. Notice how close it comes to that. And so basically it goes like that, and like that, and like that. And so that's our graph. Let's do another one. Right, and so y-intercept, so this guy, I'm going to go to the next page and do some work. So y-intercept is when x is 0. So 0 squared minus 4 times 0 minus 5 over 0 minus 3. So we get -5 over -3, 5/3. X-intercept is when you do the top equal to 0 and solve. 5 adds to give me -4, 5 and 1, negative. So we get x minus 5, x plus 4, x plus 1. This is a 1. So we're going to solve, and we're going to get x equals 5, x equals -1, 5, -1, 5/3, 5 over 1, 5/3. 5. Okay. Vertical asymptote, you set the bottom equal to 0 and solve. So if we set that bottom equal to 0 and solve, we would get +3. Horizontal asymptote, you look at the degrees, and so the numerator is 2, the denominator degree is 1, and so that's greater. And so when the numerator is greater than the denominator, there's none. So that means that the range is all real numbers, and the domain would be all real numbers except x cannot equal 3. All right, y-intercept 5 over 3 is 1 point something. Why is it not? There we go. And then -1 and 5. Vertical asymptote is x equals 3. Okay, and then let's graph it. So the numerator needs to be all in parentheses, and the denominator needs to be all in parentheses. This is slant, I guess. Okay, so I put all the numerator in parentheses and all the denominator in parentheses, and that's what we get. So it kind of goes like that, the funky one, and like that, kind of. All right, so we have put it all together.